Hello, and welcome back to the Quantum Health Connection podcast. Thank you so much for being here. I'm your host, Vanessa Baldwin, with my incredible co host, Heather Nielsen, and we are airing today part two of our podcast episode with Jonathan Jarecki. Please make sure, if you're hearing this episode, that you go back to part one and listen to that episode so you can really hear Jonathan's life story and how he got to be where he is today. This 20-year-old very knowledgeable man about science and full of health and vitality, and I really think you'll enjoy hearing his story and about who he is. In this particular episode, we really dived into the science of light, and I think that you will really enjoy it. I mean, we talked about the benefits, we talked a lot about cancer and light, we talked about healing and light, we had a discussion about red light therapy, whether we think it was good or bad, like a lot of really rich discussions and a rich, deep information about mitochondrial health and how we really make energy. Is it ATP or is it exclusion zone water? So we had a lot of really good conversations with Jonathan, and yeah, I really enjoyed it. I love hearing the science. I was like, I could listen to him all day. Like he was just going, and I was like, I love this. Let's just like, it's so great. What'd you think,
Yeah,
Heather?
I mean, he's like I said on the podcast, he's a breath of fresh air because he's so approachable, he's so personable, and some of these researchers who he's connecting with, it's not that they're not, it's just that's not their forte, that's not their focus, is to bring their knowledge, bring their findings out into the world. And I see Jonathan as a bridge because he is so excited about and enthusiastic about and pretty well steeped, I would say, in the scientific literature, because he just is, he said on the podcast, he loves to read the research. That's one of the most exciting things for him. So he's able to take that information and he thoroughly understands it. And then he's able to also, I like the fact that he's really keeping tabs on like the cutting edge, like what are we now discovering, because things are changing all the time. Like 20 years from now, we're gonna, things may look very different as far as our understanding of everything. And so, but he's able to like actually meet these people. He sounds like he's going to be working with them soon. I'm excited to see. He was kind of mums the word on that, so we'll see what happens. And then he's able to take the research and his knowledge of the physiology and then put it into very accessible and understandable terms, which is what we need. We need someone to be able to bridge those worlds, and especially somebody young, because I think, to be honest, not sounding like I don't think that young people really respect older people, but it's not the same as if it's somebody who's younger who's communicating about these ideas about sunlight and quantum biology. It's just they can relate more. I think so we need somebody who's this messenger like Jonathan to reach the young crowds so that they can see how they might want to modify their lifestyle, because they're so steeped in blue light, they're so sun deprived and all of that. So I just think he's such a godsend.
Oh my God, I love that so much. It's so true. Amazing. Yeah. And definitely follow him on Instagram and Substacks and other platforms because he shares a lot of information and it's very digestible and he makes it simple so you can understand it. So I really love that. And I can't wait to see where he goes. Please remember to rate and review the podcast and share it with people who need to hear it. And yeah, let us know what you think, of course, and enjoy it. Tell us, because you said, you set up all biology is incorrect, basically, right? That we learned. So, like, tell us some of those things. Like, tell us what's incorrect. Tell us about sunlight. Spew some wonderful, like, information to us about that kind of stuff. So, yeah, wherever you want to
Yeah.
go.
I mean, so I'll first start off saying, I think we have to sort of look at the current literature that we have, right? It's like everything's always going to keep evolving. And like I said, I'll mention here shortly the paper that the four researchers are putting out soon, because they've touched on it. I've talked with a couple of them one-on-one about it, so it's really interesting. So, and even the realm of how light interacts with our mitochondria is even evolving. So everything, even I'm about to say, especially more so with the mechanisms at play here, are continuing to evolve. So we're never, again, I never set in stone on anything, but obviously, going to share it as from what we currently understand. But yeah, I'll start, if it's good with you guys, I'll start with like sort of how light interacts with mitochondria, because I think that's a really fun place to start with.
We love it.
Go
Go
for it.
for
Yeah.
it.
Yeah, cool. So, first I'll set the stage of like what mitochondria are, right? So they're these little organelles inside of every single one of our cells, besides red blood cells don't have mitochondria, but every single other one of your cells have mitochondria. And we have trillions of cells, and inside each one of our cells, we have thousands of mitochondria. So trillions and trillions of mitochondria within the human body. And essentially what they are, right, people probably heard about them as the engines of the cell that produce what's called ATP, adenosine triphosphate, which is conventionally looked at as the energy currency of the cell. A little side tangent here. It's like, so this goes back to Gerald Pollack's work, where he references Gilbert Ling, who is this amazing researcher, and the reason we have the MRI right now is because of his sort of theory about how a
Mm.
cell fundamentally works.
Mm.
And he sort of posed that ATP is not the energy currency of the cell. The reason for that is because ATP, adenosine triphosphate, there's three phosphate groups on ATP, and the last phosphate group conventionally is thought to have this high energy phosphate bond, meaning that when that phosphate is broken off of ATP, there's this uh, basically this burst of energy that is basically given to a system, given to the cell, given to the mitochondria, whatever it is. And it's thought that it has this high energy phosphate bond. Now, Gilbert Ling sort of references some really great papers and some researchers, mainly these two researchers by the name of Podolsky and Morales. They had a paper came out. I actually shared this with my chemistry professor, where they looked at the bond on ATP and that phosphate bond, and they basically concluded that there is no high energy phosphate bond on ATP. So, if you think about that, well, then that's sort of just because so ATP is like, in the current scientific understanding, is that ATP is needed for absolutely everything, and the reason it's needed is because it gives that energy. So without ATP, no system works, and we know that, and that's for certain, that without ATP, nothing works. And so clearly, ATP has some meaningful and impactful thing on the system, but Podolsky and Morales and Gilbert Ling pose that it's not this high energy phosphate bond. What Gilbert Ling poses is ATP is this cardinal absorbent, meaning that, now going back to Gerald Pollack's work, that easy water, this exclusion-zone water, basically builds on that phosphate bond really strongly, because the phosphate is very negatively charged and it's hydrophilic. So it's going to build that EZ. And so we think, the reason why ATP is so important, because it definitely is because, not because of the phosphate bond, but potentially because of the building of the exclusion zone water. So that's just like one little thing about like how even everything I'm talking about here, like there's still so much to learn. But that's to say, we have this mitochondria, right? Trillions of mitochondria, thousands in each one of our cells. And within the mitochondria are double membrane. So they have two membranes. On the inner mitochondrial membrane is what we call the electron transport chain. Basically, this chain of protein complexes that electrons, these basically energy balls, basically get funneled through this electron transport chain to essentially eventually produce ATP. One of the last protein complex on the electron transport chain is ATP synthase. It's essentially this motor. So it's, from what I understand, it's the smallest motor that we've ever encountered, and from what I understand, it's also the most efficient motor that has ever been discovered. And when I say motor, it's quite literally a motor. It has this little rotor at the end of it that spins super fast. And with each spin, we get ATP that's produced. Now, when infrared light, so now this gets back to light. So when infrared light interacts with mitochondria, it has a few things at play here. So I'll say that the two sort of conventional, what we sort of currently understand in the scientific literature, is these two main mechanisms. The first one, which is the one that most people, especially in like the photobiomodulation world, will reference, is cytochrome C oxidase. So the fourth protein complex, so there's five protein complexes. The fourth one, cytochrome C oxidase, it absorbs red and infrared light, releases nitric oxide, allows more protons to get pumped. So as electrons funnel through the electron transport chain, protons get pumped up, basically creating a proton gradient. So you have a relatively high positive charge and relative negative charge on each side of the membrane, essentially creating a battery. So as the electrons funnel through, protons get pumped up, creating a battery charge, increasing the charge of the mitochondria. Now, when the infrared light gets absorbed by cytochrome C oxidase, it increases this charge, allowing for more ATP to be produced. That's sort of the main mechanism that we understand. There's another sort of hypothesis, and that is red and infrared light is able to be absorbed by nano water around this rotor on ATP synthase, reducing viscosity of the water, allowing the rotor to spin faster, creating more ATP. Now, there's probably there's something that definitely most likely has something to do with easy water there that we just don't fully understand yet, but I have no doubt about that. But this is really interesting. So the next this is the final mechanism, and this goes back to the four researchers in their paper that's coming out very soon, is highlighting this sort of new hypothesis around how light interacts with the mitochondria. And what's happening here is, so when electrons funnel through the electron transport chain, we have these protein complexes, and when one electron goes from one protein complex to the next, it loses energy. So it's in a less energy state, and it needs energy to get to the next protein complex. So there's an energy barrier to get from one to the next protein complex. Now, turns out when we look at near infrared light, so light is both a wave and a particle, but for this scenario, we can think of light as a particle. When we look at a near infrared particle of light, a photon, a near infrared photon, has almost the exact same amount of energy that is needed for one electron to jump to the next protein complex, which makes sense. And it's amazing because, we would have been outdoors exposed to near infrared light 24/7. So our mitochondria are built around this idea where near infrared would have been around it 24/7. So it
I
gives
was just going to
given
tell
that
listeners,
energy.
Jonathan, I want to say, where do we get near infrared light
Yes,
from? All day long as the sun is out, you will get near infrared light. So this
exactly.
is why we need to be outside, because it's supercharging your electrons, your mitochondria, your exclusion zone water
Yep.
to actually help you make energy, which makes everything in your body work better.
Exactly. Yeah, yeah. And so, we're when this near infrared light is being exposed to the electron transfer chain, electrons are basically funneling through faster and more efficiently. There's not that barrier there anymore, allowing more ATP to be produced. So you have an increase in mitochondrial membrane potential in turn, which then basically charging your mitochondria even more. So, now, I'll get to, like where are we getting this near infrared light from? And like you said, it's from the sun. So 50% of the solar spectrum is infrared light. And then when we also think about that, it's like, all right, so we have mitochondria all throughout our body. Both our skin cells have mitochondria, our eyes, our retina, our liver, everything, every cell, mitochondria. So even deep into the human body, our brain, everywhere there's mitochondria. So how is this infrared light reaching these parts of the tissues? Well, we now have peer-reviewed published literature showing that near infrared light can penetrate completely through the human body. Glenn Jeffrey has demonstrated this, where they can measure the near infrared light on the back of someone. So they can shine near infrared light on the torso, and they can measure it coming out from the other side, which is incredible, right? So this light
Which
is,
makes me think of, like, does it penetrate through clothing? I
yep.
always have
So
these questions, like, because I try to be outside as much as I can, but the winter's a little tough here in New York, right? So I'm like, I always like, I think I asked Scott Zimmerman when we had him on, and he said it does
yeah.
penetrate through clothing. I mean, not like tons and tons, but like
Well, so
it
so
does
yeah,
penetrate.
so in this paper that I'm referencing here, they also have, there's a few experiments in this one paper. One of the experiments is they shine the near infrared light through clothing. They found
Cool.
that they had 6 layers of clothing. I believe it was like
Wow.
I believe it was like natural fiber clothing, but 6 layers,
Right.
infrared light completely go through. It's not even a barrier. It goes through like it's
Wow.
nothing.
That's
So
cool.
now
That's
I
what I
think,
was wondering about the quality of the fabric, because there's
yeah,
always like, oh, it's okay
Hmm.
to wear synthetics, and it's a big brouhaha, especially with women and men's underwear or whatever, or what are our underwears.
yeah.
But that's an interesting thing, because if you make it out of synthetics, uh-oh, now what's happening,
Yeah, is it then
right?
washed? I
So if
wonder
it's
that
wool,
question.
if you got wool on, that's a better way to go in the winter.
Well,
Yes.
wool's better
Yeah.
for grounding too. Yeah, of course. Yeah.
Yeah. And so I'll
Hmm.
say with the clothing, I think, I don't know if we have, enough research on this, but I know, I've seen some people just experiment this just on their own, with a with an infrared camera and shining infrared light with like polyester and plastic based clothing. The infrared light does not penetrate very much. So I think that's
There you
that's a
go.
huge thing. If we can more lean towards more natural fibers, it has no problem going through the natural fibers very, very easily.
Nice. Cool.
That's amazing.
Even
That's cool to
even if
know.
like even if it's woven very, very close together, even if there's not big holes in it, the weave isn't large, it can still go completely through as
No
long
more
as it's,
down jackets, people. They has a synthetic, even if it's down the outside. So you got to get the wool jacket.
yep, exactly. And then obviously you're not gonna be exposed to the microplastics and all the other things. So there's benefits all around there. But yeah, so the near infrared light penetrate completely through, and then it's interacting with every single mitochondria within the human body. Infrared light can also penetrate completely through the skull. So
Yeah.
it can penetrate the skull, and then what's really brilliant here is that our brain, it has, these little crevices in our brain, and our brain is designed to basically funnel. Scott Zimmerman actually in his paper with Russell Ryder, melatonin, the opposite of the human body, they
Yes.
demonstrate this very beautifully, where near infrared light, our brain is basically designed to funnel the near infrared light deep into the crevices of the brain, so it can get into every single part of the brain. And the other sort of component and characteristic of near infrared light is that it scatters a lot. So basically when it comes into the body, it's basically going everywhere and it's bouncing off of things until it finds something to absorb. And what it is that it's absorbing it is the mitochondria. So until it finds the mitochondria, it's gonna get absorbed by the mitochondria and be utilized there. So that's sort of the idea. And then going back to this to the sun, so we can be outside getting exposed to direct sunlight and you'll have plenty of near infrared light. You can also be in shade. So even if you go underneath a tree, so what's great about trees is that they absorb the UV and they absorb the blue and they reflect all the red and infrared light. So now you're in an environment that is just tons and tons of near infrared light.
Yeah. This
And
is a
that
good point for
yeah,
clients who are sun sensitive, who are afraid to be in the UV light still. They're just not ready for it yet, or they're like, they're just kind of like they're hesitant,
yep,
right? And they say, well, do I do still get any benefit from the shade? I'm like, yes, please go
yep,
sit in the shade. Because exactly, like just being around all that greenery, you're just bouncing that
mhm,
infrared right back to you, which is exactly what your body needs. We're so lacking in it too, Jonathan. Like, I mean, we've had this conversation many times in our podcast, but when we're inside with the windows and the doors closed and you're inside with LED lighting, you are getting zero infrared and
yeah.
you are really weird. That's why it's a big reason why many people are sick is because this lack of infrared. Like we just don't have it in our indoor modern environments and people are indoors, right?
Yep. Yeah. Yeah. Standard LEDs and fluorescence in our indoor environment is completely void of infrared light. And that's really so that's one of the detrimental aspects of the standard indoor environment. We also though these lights are also just abundant in the short wavelength blue light. And blue light in isolation basically when it interacts with our mitochondria, it basically does the opposite of infrared. It basically slows mitochondrial electron flow down and reducing ATP, creating more reactive oxygen species, putting the mitochondria in more oxidative, stressful environment, which then and then at the same time, we have a mechanism that via the infrared light, our mitochondria produce subcellular melatonin, which is a very strong antioxidant. And so you're in this indoor environment that is one has tons of blue light, so you're creating reactive oxygen species, but then has no near infrared light, so you're not producing very much subcellular melatonin, the antioxidants. So now you have high reactive oxygen species without those antioxidant defense systems to combat the reactive oxygen species, putting your mitochondria in a state of high just stress and high oxidation, where it's not going to be able to function properly, and that's where we're going to see all these diseases. At the root cause of most chronic diseases is some sort of mitochondrial deficit. So
Oh,
if we can
definitely.
keep mitochondria healthy, and if we can prevent mitochondrial disease, and then also, we can even reverse mitochondrial disease with this as well by getting the mitochondria back up and running. So, and that's sort of how we can prevent a lot of these chronic diseases, and it all goes back to sunlight, right? So it's like, okay, if the infrared light, is having this amazing effect on mitochondria and it's improving mitochondrial function, then we should also see this sort of in the observational data where if the people who are getting more infrared light, more sun exposure, because 50% of sun is infrared light, well, we should see them having better outcomes, and that's exactly what we see, right? So we see people who get more sun exposure have reduced risks of all-cause mortality, reduced risk of cardiovascular, reduced risk of non-skin cancer cancers, and that's really what's important. And even chronic sun exposure, which is just regular sun exposure, it reduces your risk of melanoma mortality. So it's sort of all across the board here. We have improvements in pretty much all health outcomes as we get more. Um, it's just sunlight in general, and a big component of that, I have no doubt, is the infrared component. Now, obviously, there's a ton of other stuff with sunlight that's having an effect here, but I think that's probably a huge one. And we can even look at some clinical trials. There's a beautiful paper out of Brazil where they basically had people in the intensive care unit where they built what they called a red light sort of jacket. So they had this red light. It wasn't like a red light panel. It was sort of this little jacket that they put over the people's chest and arms and legs,
Mm.
and they cut hospital ICU length of stay by 30%. So there's a
Wow.
30% reduction in hospital
Think
ICU
about what
length of
we
stay.
could do. Like if we
Yeah. Oh yeah.
changed the hospital
Mm.
environment, right? Like if we had open windows and we had corridors or people could like greenhouse areas, people
Yep.
could go in or whatever, like courtyards and things
That's how
and
it used to be, Vanessa, right? They took it
oh,
all away.
I
Took it
know,
all
like
away. So,
you
Jonathan, do you
know,
feel like photobiomodulation and red light devices are useful, and but obviously not as ideal as the sun with the balanced spectrum? But he's got a big
right.
smile already.
Okay, so I think so sunlight is the best red and infrared light source you can ever get.
Right.
Now I actually have some concerns of like photobiomodulation devices for a few reasons. One, what so the main reason is the intensity. So if you look at these red light therapy panels, the intensity, or we measure intensity in milliwatts per centimeter squared. So the intensity of red light therapy panels can be up to, I've seen some at 850 milliwatts per centimeter squared. Now, when we look at sunlight, if we look at the full sunlight spectrum, it is 100 around 100 milliwatts, 100 milliwatts per centimeter squared. Now, if we look at one specific wavelength of the sun, let's take 850 nanometers from the sun, that the intensity of one wavelength from sun is around 1 milliwatt per centimeter squared. Now, when we look at these red light therapy panels, they only have a couple wavelengths of light. And if we look at just one of their wavelengths, it's probably 50 to 100 to 200 milliwatts per centimeter squared. So very high intensity. And this is why I've never used one, but I hear it from people where like it's hard to look at. That's why I guess people wear like the goggles. That sort of like hard to look at characteristic is that intensity of it. So super high
Mhm.
intensity. Now, I don't want to scare people. I don't think we don't have any evidence showing that it is necessarily harmful, but I think taking just the precautionary principle of it's not how we were exposed to this longer wavelengths of light. Evolutionarily, we would have been exposed at much lower intensities from the sun. Um, and then
Mm.
also, so Glenn Jeffrey has shared concerns about this as well. I mean, even in his research, I mean, he's seen tremendous benefits from 1 milliwatt per centimeter squared, which makes sense because that's we're getting low intensity from the sun. He's in all of his studies. The study that he did with the highest intensity was 40 milliwatts per centimeter squared. Ever since then, he's been going down and down and down, kept seeing the same benefits. So
Wow.
I think and sort of his stance on this is like essentially his idea is that you're basically pumping a ton of photons, the red and infrared light from these devices. You're pumping a ton of photons into the system where it can potentially, we don't know, but potentially it's like maybe clogging the system up with these photons.
Overkill, overwhelming the body.
Over like yeah, we try
Exactly.
to do
Yeah,
everything harder, faster, and
exactly.
more.
So
Like that's
so
just
I think
what
this
we
is the
do.
premise of Gemba. Like Gemba, is that how you pronounce it? This one company, they're always
yeah, yeah.
fighting. Like they'd use a lower intensity, and then they're saying everyone
Yeah.
else is doing it wrong, blah blah blah. But maybe there's merit to what they're saying.
Yeah, so yeah, I don't have one of their devices or anything, but from what I've seen, like they're doing a great job in terms of putting that intensity much lower, which is great. So now at the same time, I know people spend a lot of money on these
Yeah.
devices. I don't want to discourage them too much. I think you still utilize it. My suggestion would be distance is your best friend. So the further
Yeah.
you get away from one of these devices, the lower the intensity is going to be. That's just how the physics of it works. So
Mhm.
you can either one, just be far away from it, or two, like literally turn it, or especially if yours has near infrared light, if you turn it around, face it against a wall, the near infrared light's going to bounce off the wall, come right at you. So you don't need
Mhm.
to. If it's red light, it's going to much of it is going to be absorbed by the wall itself. But if it's near infrared light, it's going to bounce off and come back out. So
Yeah, like I have done that in the past where I have a red light panel, so sometimes I won't sit in front of it, but I'll just put it on in the room that I'm in, right? So I'm not near it, but like because I want to put more infrared light in my
yeah,
environment. So like I open the window, I'm sitting next to an incandescent light bulb. Like I try to bring infrared into my
that's the best.
environment when I'm stuck indoors. Like I mean, I do have to work, right? Like so sometimes I
Yeah.
have to be indoors, right? So I want to be outside all the time. I tried to work outside. There's it's always like a conundrum of a problem.
The podcast, Jonathan, with her outside, and I'm like, it's getting a little noisy.
Yeah, like so there'd be like leaf. As soon as I said that, someone's gonna put a leaf blower on. I'm like, you no, I was so quiet in here 4 or 5 minutes ago. So anyway, so I have done that, which that's a great strategy, I think, like to put it in the room that you're in, so you're not necessarily like, but it's like bouncing off into the environment, so it's giving the environment more infrared when you have a day where you have to be inside more.
Yeah,
That's my
I
thought.
think I think outside of the sun itself, I think the best red light therapy device would be an incandescent light bulb. I
Yes, yeah, that's what
love
I
like
sit next to. I
yeah.
sit next to an incandescent light
Yep, there you
bulb.
go. Exactly. I mean that is the best. I mean even so Glenn Jeffrey has even shown this. I mean he's So he had a study where he shined 670 nanometer, which is red, light into participants' eyes for 3 minutes in the morning. He showed improvements in visual function of their eyes. Now, he also then went and on and did a similar study where he just used an incandescent bulb.
Mm.
When he used the incandescent bulb, he saw better improvements than just the single wavelength of red light. So I think
Mhm.
without a doubt, the incandescent bulb is way better than any red light therapy device you're going to get, even though it doesn't look as
Nice.
fancy and doesn't, seem
I
like
know.
you're
I
getting all
know.
the
Not as
benefits.
expensive.
Not, yeah, oh my gosh, way cheaper, right? So, yeah, that's my concerns around the red light therapy in general.
I think that's valid. And
Yeah,
we evolve with the sun. We're meant to be outside there. That's our best source of infrared. I think people I understand sometimes if there's injury, infrared could be
yeah,
very
yeah.
helpful.
You-
Like if you have a soft tissue injury or something like that, that's also a supportive way to use it as well. And I think some people who unfortunately are still stuck in systems and they're not able to get outside and they're really lacking like near infrared light. It's a way, I don't know, maybe getting that burst because I've seen it be effective, like to
Mhm.
helping people heal, like getting that burst if their environments are so not, they're poor,
Yeah,
So
yeah. I mean,
yeah,
we have published literature showing that these high intensity devices are showing improvement. So I think
yeah.
there can definitely be a use case for it. I'm just simply saying, the best way to just
The
go ahead.
best case scenario,
Yeah.
yeah.
But it can definitely be utilized. I think it's definitely though for someone who doesn't have an injury or anything like that, shouldn't be shining on you like very close and every single day. I think it's probably overkill.
Yeah, very cool. Yeah. Anything else you want to tell us about sunlight and its benefits besides near infrared, subcellular melatonin, of course,
Go for it. Yeah,
amazing.
yeah,
Yeah.
yeah. I think going into the shorter wavelength side of the spectrum, which is the UV,
Yeah.
there's tremendous benefits with UV as well. And UV gets demonized a ton, which
Mhm.
which I mean, sort of rightfully so in the sense of UV, yes, itself. When we isolate UV light, we can shine it on cells in a little petri dish, and what happens is those cells they turn cancerous because the DNA is breaking and there's no DNA repair mechanisms there, and the cells aren't even connected to the rest of the body, so you have that problem in and of itself. Like that aside, yes, isolated UV light causes DNA damage, and it can definitely lead to skin cancers and things like that when we isolate UV light. Now, the sun is not isolated UV light. The sun is the sun. So when we look at the sunlight spectrum, less than 10% of the sunlight spectrum is UV. Only, I don't think most people know this, only 0.13% of the sunlight spectrum is UVB. So UVB is the part of the wavelengths that is going to create the tanning response, and then also is what produces vitamin D. Um, but and then around like 9% is UVA. So there's
Mm.
that, right? We have the majority of it is infrared. So we're not dealing with isolated UV light, which is the big thing here. Now, when we do look at UV light, there's tremendous benefit. So I'll talk about UVA because I think that's really important. Most people know about vitamin D, and when people go outside, they go in their sun, they get their sun just for the vitamin D benefits. And there's a lot of benefits with vitamin D, no doubt about it. But that is to say, we have plenty of epidemiological evidence showing that people who have higher vitamin D status, they have higher blood vitamin D levels, they have reductions in cancers and reductions in cardiovascular disease. However, when we go into clinical trials and we supplement people with vitamin D supplementation, just give them vitamin D in isolation, we don't see these improvements in these chronic diseases, which is really interesting, right? So that sort of gets the question, all right, well, why are we seeing this observational sort of correlation with people who have higher vitamin D levels? And I think a lot of people in the space think this is that what we're really seeing is vitamin D is simply a proxy for how much sun exposure someone is getting. So people who get high, and we know this also. We have great observational, very strong research on this, where people who get more sun exposure have higher vitamin D levels, and it makes sense. Obviously, we know the mechanism, and we know that UVB light produces vitamin D. Now, another point there is like when UV light, so it interacts with so we have cholesterol molecules in our skin, and when it interacts with cholesterol, it breaks the bond, and it then produces vitamin D. But in sort of in between the cholesterol molecule and the end product of the vitamin D, there's 50 other metabolites of vitamin D that occurs as well. So not only when you're interacting with UVB are you getting the vitamin D, but you're also getting the other 50 metabolites that I know we do have some research on some of the metabolites, but we haven't really studied it very much because we've just been so focused on the vitamin D part of it. So I can almost
From
guarantee
what I know,
that.
Jonathan, from Carrie Bennett's research or what she's taught me or and others is that those metabolites that we get from the sun versus the vitamin D3, right, in a pill, are the ones that are actually cancer preventative.
Yeah. Yeah.
Yeah.
So, I mean, when you take a vitamin D pill, you're only getting one of, for the most part. I mean, maybe
Yeah.
some will have a couple of the metabolites, but for the most part, you're only getting the vitamin D3, 25 hydroxy vitamin D3. And so that 25 hydroxy vitamin D3 is you're only getting one of the 50 other metabolites that are
You're getting a
occurring.
part of the whole, you know?
Yeah. So
It's
that,
like the vitamin C ascorbic acid, the
yep.
whole food
Yeah.
vitamin C versus ascorbic acid, content.
Exactly. Yeah, yeah. So there's that with the UVB. And most people understand, you're getting the vitamin D there. But there's so much more. So with UVA is super important. So Dr. Richard Weller has done fantastic research around this. He's a dermatologist. He
I love that.
he jokes, I've heard him on a couple of podcasts joking about how he has no dermatology friends. Because so when he was first sort of starting off in the space, he was trying to figure out if nitric oxide has any relevancy to preventing cancers and skin cancers. And there was nothing. He wasn't really getting anywhere with his research. I mean, he's published like some interesting stuff in it, but he wasn't really getting anywhere where he thought he would get with it. But then it turned out that he discovered that people who get more sun exposure and get more exposure to UVA have lower blood pressure. So people who are at higher latitudes have lower blood pressure, and this is independent of temperature because we also know temperature can affect blood pressure. Independent of temperature, people who have more sun exposure have lower blood pressure. So we saw that. He was like, that's interesting. And he essentially started doing experiments. And what he found is that when we expose people to, and we have randomized placebo-controlled trials on this now, that him and his colleagues have done. When we expose people to UVA light, and the reason he used UVA because it's also UVA and UVB, but he used UVA because he wanted to see if there was a vitamin D independent pathway here, because UVB is the only vitamin D producing wavelength. Now, so he used UVA, shined it on participants, and what he saw, he measured their blood nitric oxide level. So nitric oxide is a super, super small molecule, just NO, nitrogen and oxygen, bound together. And there's a lot of very good cardiovascular benefits with nitric oxide. And what he found was that when we shine the UVA on people's skin, we all of a sudden see this huge sort of spike in nitric oxide levels in the blood. The reason for this, he later discovered, is that our skin stores nitric oxide. So in our skin, in our dermis of the skin, there's nitric oxide stores, and there's nitrate and nitrites, which then get converted into nitric oxide. And so there are these stores of these nitric oxide producing molecules. And when we get exposed to the UVA, those nitric oxide molecules get shuttled into the bloodstream, and then our blood vessels vasodilate. So it opens up your blood vessels. If you can vasodilate your blood vessels, you can reduce blood pressure. Then if you can reduce blood pressure, you can improve cardiovascular benefits and cardiovascular effects. And so he has shown this. He's shown that we shine UVA light, increase nitric oxide. He's shown that also then in turn reduces blood pressure. And then when we look at the epidemiological evidence, he has beautiful evidence showing, looking at the UK Biobank, 400,000 participants, looking at their UVA exposure with satellite imagery, with vitamin D status, and with surveys. So taking all these sort of proxies for sun exposure. And he showed without a doubt that as we increase sun exposure, as the people who get the most amount of sun exposure, they have the lowest rates of cardiovascular disease. So there's no doubt about it that this UVA light is affecting the cardiovascular system in a very, very positive way. So we're having pretty huge reductions in cardiovascular disease when people get more and more sunlight exposure. And this goes to sort of that UV spectrum side of the spectrum. Now, there's also some interesting evidence going back to Gerald Pollack with the exclusion zone water and infrared. So far infrared light around 300 nanometers does it the most, but all infrared light pretty much generally can essentially increase this exclusion zone. And in our blood vessels, we have what's called the glycocalyx, which is sort of this sort of basically this area around, within the blood vessel. And he has a great paper on this it's in a chick embryo. But I think it's the paper was done really beautifully that, I mean, with a lot of this stuff, I don't need more evidence to tell me that the sun is beneficial. But I mean, it's great if we can get more. Great if we can get more evidence on this. But within the chick embryo, he's shown this, and it's very beautiful experiment. that the easy water actually forms within the blood vessel, and when you shine the infrared light, so you shine the infrared light, the easy water builds on the glycocalyx because the glycocalyx is very hydrophilic. And now
Mhm.
what he sees is that there's an increase in blood flow. This is independent of the heart. So he stopped the heart of this chick. So heart's not beating,
Wow.
blood's not flowing.
Mhm.
Shine the infrared light, the blood starts to flow,
Wow.
which is incredible. So without the heart, the
Manuscript.
blood
Yeah.
is flowing.
Mhm.
And this sort of gets to this idea that where it's like even, separate from the UVA, we're increasing blood flow just from the infrared light. So, and again in science, we're isolating these specific wavelengths, but really at the end of the day, it's like when we're going in the sun, we're getting all these wavelengths at once. We're never going to understand as long as we keep on this reductionistic path with science, we're never going to understand the full benefit that we're seeing here. But definitely when we are, when we're isolating, we're seeing these benefits. I bet it's even more when we're getting out in real sunlight. But yeah, so that's sort of the shorter wavelength side of with the UVA, and I think it's important to touch on this point here with the skin cancers, because obviously I think that's what people first think about when they think about, oh, UV light from the sun or just sun in general increases your risk of skin cancer. So when we look at I'll just share with like what does the research that we have show, right? And what it shows is that if we increase the people who get the most amount of sun exposure, there is an increased risk of basal cell and squamous cell carcinoma. So these skin cancers that generally are not too, I don't want anyone to get skin cancer, but generally they're not terrible. No one People aren't dying from
Yeah,
basal
they're
cell.
not as life-threatening. Right.
Exactly. They're not life threatening. And now what is life threatening is melanoma. So melanoma, there is a mortality rate that is concerning with melanoma. And when we look at the literature around melanoma, every single study shows that as you increase chronic sun exposure, so that means regular sun exposure, so going
Right.
out
Not
regular,
intermittent, not meaning
yeah,
like, okay, I go out, I don't get a base, I burn, right? I go out on a daily,
exactly.
regular base,
Yep.
I build a solar adaptation, and
Yep.
I'm a partner with the sun, right?
Exactly. Yep. As we increase that regular sun exposure, what we're seeing is we have a reduction in melanoma mortality. So there's an inverse relationship there.
Yeah, I
Which is
want to putting in something with this cancer topic is also
yeah,
that sunlight exposure reduces risks of breast cancer, uterine cancer, prostate cancer, ovary cancer, like all of these kinds of cancers that
yep,
are much more pancreatic cancer. These are much more deathly than a basal cell or squamous cell. So I would, trade being in the sun and maybe a chance of getting those to having breast cancer or ovarian cancer or cervical cancer any day, as a
exactly.
woman.
Exactly. And
So
and even and even going to those studies where those observational studies where we are seeing increase in basal cell and squamous cell carcinomas, they'll say in the papers a healthy population, but we know that the population that they're looking at is not healthy. All they mean by a healthy population is that they don't have diabetes yet, they don't have cardiovascular disease yet. So that's what they mean by a healthy population. But I would sort of argue that if you're truly a healthy population and you actually have the sort of everything that we're talking about and all the lifestyle approaches that actually lead to a healthy life, I would probably see if you looked at a population like that, which there probably isn't a big enough maybe I hope there's a big enough but I don't know. To do a study like that, we probably wouldn't see the increase. So there's a lot of other lifestyle factors that are playing with that correlation that we're seeing there. But even like you said, even so, even if it is true where you do increase your risk of those skin cancers, again, you're reducing your risk of cancers that are actually harmful that we actually want to prevent that are killing people. So there's a paper in defense of sunlight where they look at it, and it's I believe there's 15 different types of very deadly skin cancers in general that are dramatically reduced. The risk of them are reduced when you get more sun exposure.
yeah.
So that's that idea there, and I'll also say like the reason dermatologists think this is again because they're looking at isolated UV under the microscope in cells isolated from the human body, and that's what we're seeing, so it's this idea of the
Yeah, we
sun.
don't have the infrared and the subcellular melatonin doing their jobs in that
Exactly.
petri dish.
Yeah, exactly. So it's all this it goes back to the reductionist of science there. But again, this just points to the idea that the sun is doing more benefit than harm. I'll just end with this one small point here. So Richard Weller is also there's a preprint out right now. He put this preprints basically are, these before a paper gets published, researchers, if they want, they can put it on a preprint server for the public to see before it gets peer reviewed or anything like that. And he looked at the risk benefit ratio of sun exposure. So looking at
Mhm.
the risk, those potential skin cancers, and looking at the benefit, the reduction in non skin cancer cancers and cardiovascular disease and all cause mortality. And he crunched the numbers, looked at a population of 400,000 participants. I believe it was the same UK Biobank participants, and it was beautiful. He basically did this risk reduction analysis and showed when you put all the numbers down into one little ratio so if you put everybody, he had three groups. He had a low UV, a medium UV, and high UV. If you put everybody from the high UV and the medium UV and put them in the low UV category, so he used some data analysis to conduct this. But if you put all those the medium and high UV people, put them in the low UV category. So essentially telling everyone who's getting a lot of sun, are you stuck inside, like you're locking them indoors, right? If you're doing that, what you're going to see is you are going to save one life from skin cancer. If you crunched all the numbers down, you'll save one life from skin cancer, but you would lose 75 lives from non-skin cancer cancers and cardiovascular disease. So
Wow.
that's the risk benefit reduction in
Yeah.
ratio
So
there
just
that we're
don't
seeing.
fear the sun, go outside. Obviously, I mean, we say it all the time, but yeah, I mean, it's like obviously that's the way you want to go.
Exactly. Yeah. So I think, hopefully, dermatologists will come around to this. I mean, Richard, well, I think he's the smartest dermatologist out there, but hopefully he
Yeah.
can have an influence on some of the people in his field and his
Yeah.
peers, to sort of, look at sun exposure as more than just skin cancer and looking at what are we actually doing outside of
Right.
the
There's so many other factors that are contributing to cancer besides
Yep.
sun, first of all. Like
Exactly. Yeah.
Heather and I would talk about the mental emotional piece of cancer. We actually had a great podcast with Paul Linders. That was such a great podcast we had, Heather, and that everybody should go listen to that one if you're worried about cancer. It's stemming really from more of the mental emotional piece than anything,
Yeah.
right? So,
Yeah,
I
we didn't
mean,
mention that earlier. We mentioned suppression from medications, but we didn't mention the suppression of our humanity
yeah,
emotionally, right? And so that was a really popular podcast.
yeah.
Jonathan, is that he would go into people's homes. I don't know if you know who he is, but
I think I've heard the name. Yeah.
it's pretty incredible with cancer. So he, in several months, in working with them emotionally and lifestyle ways, he would help them go from stage 4 to like in remission. I mean, it was really powerful stuff. So
Amazing. Yeah.
Mhm. Right. So there's many other factors that are contributing besides sunlight, first of all. Like we can't isolate it again that we just blame sunlight. We're blaming the light and we really need it for our biology to function optimally. Like it's a nutrient that we all need, right? So I am
Exactly.
so glad, Jonathan, that you're putting all this information out there. I love to see that you're growing, you're very popular on Instagram and like those reels go out. That's how I found you, right? Like I
Sure.
love to see that because
Yeah.
my algorithm was like, oh, she likes sun here, but let's give her Jonathan, right? And I love that because then I can repost them and share them, and then people are seeing this information because we need to like people need to know because sometimes I think like they know because I'm in the space with all people who are like-minded a lot, and I'm like, oh no, no, no. Like we have a lot of work to do. So I'm so glad to see you doing this at such a young age. I'm so grateful for it. I know we're getting close to the end here, and I want you to leave listeners with maybe tips or what would you, I also wanted just thinking like, what would you say to like people of your, age group and generation, like about this information? So those kinds of things, like tips that you would recommend or like, things like that.
Yeah, yeah. I'll first start with my generation. Yeah, one of my big passions is like getting kids my age and my generation sort of, in better health because I think, we're next up in terms of just like everything. And, we
Yeah.
want a healthy population. So I think the biggest thing is, the body's very resilient. And I think one of the problems with that is that, as young people, we don't see sort of any negative consequences. We can eat junk food and still feel okay. And we can do all these things and still feel fine. We're not, obviously we're not thinking about long term, but there is obviously a long-term consequence. So I think just like hearing that and knowing that there is a long-term consequences and these chronic diseases that we are seeing that I think, most people have at least has someone in their life who has been burdened with some chronic disease. And I think if we can just understand that that lifestyle has an impact there and that it's preventable, absolutely. I think that's the key thing and really, starting to implement things small So start changing some things here and there. You don't need to do a complete 180, although that would be amazing, but you don't need to do a complete 180. Like start small, start implementing little things here and there. Get morning sunlight. I honestly think if we can get people to just go outside in the morning, I think that's probably one of the biggest things to push the lever the furthest. Just because it's such a simple thing, and I think it has such a profound impact on so many other aspects, right? It's like, most people my age, they wake up, they reach over the bedside table, get their phone, start scrolling, and that's the first light they're exposed to. But I think if we can just, go outside and scroll. So like, get outside, go outside, start scrolling on your phone there. Like, do
It's a good compromise.
It's
that would
better
be,
than being into bed and scrolling. I'm like, okay,
yeah.
put the phone away, just go outside,
Like
barefoot,
that would be
orient,
best.
maybe have some gratitude. Like I want to push it further.
Yeah. No, for sure, for sure. That would be best. But I think it's the simple things. And then yeah, I mean just practical takeaways for everybody. In terms of light, I think, the best thing, again, what I love about this is like, yes, the science can get complex, but the takeaway, super, super simple. It is in the morning, at the very least, very minimum, at least within the first hour of waking up, head outside and get 20, 30 minutes minimum of sun exposure into the eyes. If you can, my suggestion is go outside at sunrise. So wake up for the sunrise, view the sunrise, stay out there for as long as you can, get those wavelengths and the light exposed to your eyes and to your skin as much as possible. So that's super simple, easy thing. And like what's great about that is like, all right, if you drink morning coffee, you go drink your morning coffee outside. If you read the newspaper, go read the newspaper. If you scroll on your phone, go scroll on your phone outside. Like whatever you typically do in the morning, just go do it outside. It's super simple. Just change in your environment of where you are. That's like I think a really foundational pillar. And then the other thing would be to get as much darkness at night. We didn't really touch on circadian rhythms a whole ton, but the circadian system governs almost every single cell, every single organ of the body, and it's that brightness in the morning and that darkness that we want at night. And again, this is also going to have an effect on your mitochondria as well. But getting that darkness. So for people who, let's say, they don't have circadian friendly lighting in their house, or let's say it's just a standard person, like even if you can, the first step is like dim the lights at night. Okay. Even if you have overhead, bright blue, white, blue enriched
Better
light,
than nothing, right? Yeah.
just dim the lights. That's first step. The best thing to do is, to have remove no overhead lights at night because the circadian system gets highly stimulated via that overhead lighting because, the sun is always overhead. It's never below you. Obviously, it's at either horizon or above. And so any light overhead is going to stimulate the circadian system a ton. So getting light bulbs and lamps is really beneficial. So just turning on lamps at night. And then also, then furthering that and going into, utilizing circadian friendly light bulbs. So bulbs that are void of any short wavelength blue and green light. And then, if you can, which would be ideal, like also bulbs that are enriched in infrared. So the incandescent light bulb that you showed me, the amber tinted incandescent light bulb, rich in infrared, super beneficial there. You just want that dim environment at night to sort of anchor in that circadian system for the nighttime. So those are sort of the two like just foundational pillars of circadian health, but then also, light health in general. And I think another just nice, easy takeaway is like buy an incandescent light bulb, place it on your desk, on your work desk. Easy, simple as that. If you can be near a window, that's great as well. Have that dynamic lighting throughout the day as well as keeping that incandescent light bulb on your desk. If you can open up a window, even better. The more breaks you can get and go outside as much as possible. So if you have a 10-minute break, go take the 10-minute break outdoors. If you have a lunch break, go take the lunch break outdoors. That's probably the biggest thing because, you're spiking your blood glucose levels. If you are doing that in an indoor environment enriched in blue, those blood glucose levels are going to be even higher. Blood glucose regulation is not going to be optimal. If you go outside with tons of red and infrared light, you're going to allow your mitochondria to utilize that food that you just ate in a more efficient way. So those are some easy, just practical things. I'm also a big proponent of for nighttime, like red tinted blue light blocking glasses. So if you can't control your indoor light environment, which not everyone can, I'm in school. I go to club meetings at the end of the day at night because that's when everyone's
And
free.
you
No
wear
one
your blue blockers?
yeah, oh yeah.
Yeah,
I have my
cool.
blue blockers on. I got my hat
Nice.
on, so not
Nice,
allowing to do the
nice.
light
Yep, good job.
the top. I cover as
Yeah,
much skin as possible because our
good
skin
work.
has photoreceptors on it, has
Yeah,
melanopsin.
Yeah.
which absorbs the blue light as well, although it has less of an effect on your central circadian.
The eye is the most important, but the skin
Yeah,
does play a role. So,
exactly. Eyes
yeah.
are most important. Skin plays a role. You know, your skin cells have a circadian system, and it utilizes that light that's touching your skin as well. So there's a component there. But yeah, I think those are some pretty, good practical takeaways, and keep learning. I think that's the biggest thing. Keep learning, keep questioning, and I think that's the best thing for people to do.
I love that. Jonathan, this has been so fun. I could talk to you for literally hours.
It's been a
So,
lot of fun.
I
I
mean,
enjoyed it a lot.
anytime you want to come back, you're welcome back. And also, please tell people where they can find you. I mean, I know you're basically mostly Instagram. I think you have some other platforms too, though. So please tell people where they can find you.
Yeah, yeah. On Instagram, just my first and last name, Jonathan Jarecki. Also on X, Jonathan Jarecki. And then I've been sharing some stuff on X. I have a Substack as well, which
Nice.
I've been going a lot like deeper into a lot of this stuff because obviously social media, 60-second Instagram clip, I can only say so much. And then
Yeah.
I mean my whiteboard videos I go up to like 3 minutes, but even with that, I have so much more to
So
say.
hard. Yeah,
When
it's
I'm
hard.
editing those whiteboard, because I don't really have a script for them. I just like draw my stuff and then like I'm like, all right, let's start talking.
I
And so
love
I
it.
don't really have a script for them, but so I'll just keep rambling. And then when I'm going to edit, I have like so much stuff to take out. I'm like, oh, I don't want to take out this. I don't want to take out.
I have the same problem. I have such trouble sticking to 3 minute reels. When they
Yeah.
switch that over, I was like, oh, I used to do like 5 minute ones because it's just so hard to get like the real meat of everything in there that you want to say.
Yep.
But yeah, you're doing a
Exactly.
good
So
job.
that's where I think Substack is really helpful. So I've been doing some like really deep dives there. And that's just I think people can find just the signal. The Signal is my podcast and also my newsletter with my Substack, The Signal with Jonathan Jarecki. That's my podcast as well. So people can find me that way. If people want to contact me, the best way is Instagram DMs. I reply to pretty much all my Instagram DMs.
Wow.
And yeah,
Nice.
so try to help people out there as well. So if anyone has any questions, feel free to just let me
Oh,
know there.
Wow. Well, thank you so much, Jonathan. I mean, just a wealth of information. And I mean, I like in 10 years, you're going to be in the stratosphere. It's just really impressive.
yeah,
And
it's
thank
great.
goodness you're going to be able to, because not all researchers and scientists are really outgoing or really, you know what I mean?
Yeah.
They're not like out there in the public spotlight. So I'm looking forward to you being the one who's going to be the bridge there. Absolutely.
Thank you. Yeah, no, I appreciate that. I hope I can be that bridge for people. So that's the goal.
Yeah, I think you already are. It's beautiful. Amazing. I love it. Thank you so
And
much, Jonathan.
it's a lot of fun.